Hey everyone, this is Richard from 1698V here, and today I'll be doing a quick code explanation of our red gold rush Auton that got us all the way to the World Championship Finals. And if you're new to Vex or you're looking for better programming or Autons, I recommend that you check out RW template, which I've included the red gold rush Auton with, so you can get a good idea of how I program such great Autons and how you can do them too using this template. And the Auton I'll show you a quick video of is the one that starts over here. This spot right here.
Let's go! Let's go! Finals match number 1 underway. Clean so far. Trying to find a champion. Red Alliance has one ring in the bottom in blue. Doesn't really matter.
If you want to learn more about this or want to see more about how I did it or want to test the code yourself, you can come check it out on the GitHub over here. And so yeah, let's start off by looking at the code. So first of all, I declared some local variables here about like the arm to know which angle to set the arm to for different things such as the PID, or like to know what angle would score onto the wall stake, what angle to store the ring at, and what angle to load the ring into the Lady Brown at. So first of all, let's look at the arm PID function. And this is actually just the update function because I called it in a loop with the arm PID loop over here to constantly update the arm position to my desired target. And over here, I just set a bunch of like the specifics that I wanted out of it, such as like not using any I, or like how long I want it to settle for. Yeah, so let's talk about the rush clamp. And oh yeah, I just want to say that all of the functions over here aren't really are kind of I mean, they could be applicable to next year's game, but they are specifically designed for high stakes. So these helper functions, like, it's specifically for high stakes, but you can use these as an example to write helper functions for a pushback. And let's talk about the rush clamp function. So basically what this does is it looks at the distance sensor inside of our rush claw over here, and sees when the goal is close enough to clamp down. And when it does detect that the goal is close enough to clamp down, it does it immediately so that there's no delay. And this is really effective because some other teams, what they do is they simply drive to the point or the location and then clamp down. However, this is not as efficient as using a distance sensor because the distance sensor does it as soon as it sees the goal, whereas other people need the bot to arrive at the location and settle down or before it can clamp down onto the goal. Yeah, so basically we close the claw and then we lowered, we also raised the rush arm because we want to hook onto the goal just in case we didn't clamp down early enough or we didn't clamp down properly. And hooking it up used by raising the rush arm is just like a guarantee. Let's talk about the intake thread function now. So basically what the intake thread function does is it uses the optical sensor and the distance sensor inside of the intake to detect when a ring has been intaked into the bot and know when to stop and hold the intake so that we don't continue intaking and let go of the ring. And this is really effective when we want to store a ring inside of the robot for future uses. So starting off, let's talk about the start of the Auton. So basically I reset the Lady Brown to the load position because I start with a preload inside of the Lady Brown over here. And then I put down the rush arm and I spin my intake with intake thread to intake the ring over here and hold it inside of the bot. Then I back up. Then after I rush, I back up and I hold the chassis so that the bot stops moving, and I can, because this is actually a a chained exit condition because I want the bot to back up at full speed when we're trying to compete against other teams. And this also, you might also notice that this has a 15-second timeout. And the point of this is just in case there's a stalemate, we want to guarantee a tie in the Auton on the positive side. So I'll show you this section of the code right now. This section. Um, yeah. Wait. It's up to here. And then what I do after that is I kill the thread for the rush clamp, and I put the arm down so that it no longer hooks onto the goal, and I let go of the claw, and I wait a bit so that all of these pistons can finish their task before I doing what I do what I before doing what I do next. So after that, I basically drive forward a bit to push the goal, and then I back off because this really helps with consistency when unclamping the goal, just in case we clamped it at a weird angle or something where the goal is stuck on our hooks, which this prevents by pushing the goal forward. And I set a correct angle because I just want it to be more consistent when at the angle that like I release the goal at and things like that. So yeah, this basically sets like what angle that the drive to corrects heading to when I do these tasks. After that, I I raise the rush arm because I want to retract it, and then I go and clamp onto this goal over here. And you may notice that I use a chained exit condition for the turn here, which is because I want the bot to turn a certain direction, but after that, I want the move to the point to handle the rest of the turning and get it to its desired location. And I continue backing while I grab the goal because the momentum in the goal is conserved. So if I were to simply break the bot or stop it, the goal would continue moving and you may not be able to clamp onto it properly, which is why I clamp it while moving backwards. Yep. And then after that, I interrupt the intake thread because I don't want to hold it inside of the ring inside of the bot anymore, but I now want to intake it onto the goal. And then I move to this position over here to drop the goal, and I turn to drop the goal near the corner. And yeah. And after that, I try to clamp this goal over here, but before that, I have to push this ring out of the way because it's the opposite color and I can't intake it. So I go forward to this point while reversing my intake, and then I do a really similar thing to get this goal, which I did with this one. Yep, after that, I turn towards the corner and then I move to this point over here to get ready to intake the two red rings in the corner. So actually over here, I do a drive two for infinite distance and I rely on timeout to pause it because I want the bot to go fully into the corner no matter what position it is in right now, and at like a 45-degree angle from horizontal because like in taking this red ring you have to go fully into the corner in order for our bot to intake it. And then I also limit the speeds with max output over here because I don't want it to completely mess up the stack of rings in the corner. So yeah, and then after I go into the corner fully, I back out and I intake the second ring. Yep. And after I intake both of those rings, I go get ready to score on the wall stake over here. So first I back up, then I turn to face the wall stake. Then I reposition the arm to get ready to score onto the wall stake. And I move to the position near the position of the wall stake. Then I start spinning the arm down to get ready to kind of like push onto the wall stake to make sure I'm touching it. And then I turn to face a final angle, which is to face the wall stake. And then I also drive forward at a really slow speed to make sure I touch the wall and have the best chance at scoring the wall stake. Yep, that's it for 1698V's robot autonomous explanation. And if you want to learn more about my code or are looking for a template to use for the next new season with many amazing features, you can check out RW template over on the GitHub here, and make sure you start it with this button over here. Then also make sure you join the Discord over here to contact me and learn more about the template itself. Thank you.